Boom! Yes, folks, Hume again. How are you going? This is the fourth video in our series on factorization. In the first video, we covered the univariate binomial. In the second video, we covered the bivariate binomial. In the third video, we covered factorization by groups. And we said at the end of that video that factorization by groups is something that leads you straight into quadratic factorization. We said then that quadratic factorization is essentially factorization by groups. Of course, there are other aspects of it as well, but factorization by groups is a very, very key component coming down to the end of the process, and you will see that in a little bit. Before we get into the factorization itself, however, we want to take a little time just to discuss the quadratic itself, right? We want to be able to recognize a quadratic expression first of all. A lot of people doing maths exams and they're doing maths and things, and they don't know what a quadratic expression looks like. If you tell them, write a random quadratic expression on the board, they can't do it. If you put an expression on the board and you tell them, what kind of expression is that? If the expression is a quadratic, they wouldn't be able to say that it is a quadratic. So you want to spend a little time just discussing that first. You absolutely need to be able to recognize a quadratic because for exam purposes, more often than not, they will not tell you that the expression is quadratic. They will just say, factorize 2x squared minus 3x plus 4. Factorize x squared minus 7. Factorize 9x squared plus 9. Right? And you are the one who would be expected to know what a quadratic is and what it is not. Because if it is not a quadratic, of course, you will have to factorize it using some other method. Right? If it is a quadratic, then you factorize it using the methods that we're going to use for factorizing quadratic expressions. Alright? So we're looking at the univariate quadratic because we have a bivariate quadratic as well. So let me start with the bivariate and go back to the univariate. Right? With the bivariate quadratic, there's a lot more variation in terms of how that could appear than there would be in the univariate quadratic. Right? So a typical example of a bivariate quadratic, we're not going to get too complicated now, would be something like xy minus 3x plus 4y minus 7. That is a bivariate quadratic. Right? If you want to get technical, you could even say that the equation of a circle is a quadratic expression in two variables, which makes it a bivariate quadratic. So just, again, very quickly, all right? If we have a circle, let me say x squared plus y squared minus 3x plus 4y minus 25 is equal to 0. Right? Something like that. That's the equation of a circle. And as you could see, we have two variables. Right? We have our x and we have our y. And the highest power is 2. That is what makes it a quadratic. The highest power is 2 here as well. But the powers appear a little differently because you have x to the power of 1 and y to the power of 1. So you have a expression here where you have two variables multiplying by each other to give the sum of the powers adding up to give you 2. You will see why that is important in a little bit. Alright? So anytime you have an expression in this case it's two variables, either looking like this or looking like this or looking any other how, where the highest power is 2. That is a bivariate quadratic. The quadratic that we're particularly concerned about in this video, however, is the univariate quadratic, which generally is a lot more limited in terms of how it appears. Right? Because it is univariate, it will generally take the form ax squared plus bx plus c. there isn't too many other ways in which you could express a univariate quadratic. This is what we refer to as the general equation. The general equation? The general quadratic. Let me leave it like that, because unless there is an equal sign here, we cannot properly refer to it as an equation. So this is the general quadratic. Ax squared plus bx plus c, where you have a value of a multiplied by x squared, you have a value of b multiplied by x, and you have a c, which is a constant, right? Just as we discussed a little while ago with the bivariate quadratic, as you can see with the univariate quadratic, we only have one variable, x, but the highest power of x is 2. If that highest power of x is anything else, the expression cannot be considered as a quadratic expression. If the highest power is 3, then it would be a cubic expression. If the highest power is 4, then it would be a quartic expression, etc., etc. Right? I dealt with all of those things in a little more detail at the start of my AddMaths videos on polynomials. You can check that out if you want. So you have one variable x, which means that the highest power of x is 2. You have two variables here, but for both of those variables, the highest power must be 2. Right? You have x squared here and you have x squared here. You have two variables here. So even when you combine the variables by multiplication, the highest power must still be 2. Right? So in other words, you can't have x squared y in this equation here in black, or xy squared. The only thing you could have is xy. Anything else, in terms of combining the x and the y by multiplication, will not give you a bivariate quadratic. And of course, the quadratic being an expression where the highest power must be 2, you cannot have a trivariate quadratic. Because if you have 3 variables and you do this, x, y, z, the minute you multiply x by y by z, your combined power is equal to 3. Because you have x to the 1 by y to the 1 by z to the 1, 1 plus 1 plus 1 is 3. Alright? So for a quadratic expression, you could only have up to 2 variables. The particular version we're concerned with here is the one with one variable alone. And there is no special law in the universe that says that the variable must be denoted by the letter x. The variable could be denoted by anything. So we could say, for example, come drive fast, drive fast, drive fast. You see how we did have to be when we doing this thing, right? We writing and we cleaning the board at the same time. So a quadratic could look like, let us say, 2k squared plus 3k minus 45. That's a quadratic. You can have a quadratic that looks like, let us say, 11w squared minus 44. That too is also a quadratic. You could have, let me say, 9y squared minus, let me say, minus 65y. That's a quadratic too, right? You could have also, let me see, w squared, dam, dam. Right. You could also have, let me see, you can have minus 12p squared minus 13p plus 6. That too is a quadratic. Alright? So the main thing is that the quadratic will always have a square somewhere in the expression, and that will be the case because of the fact that there is one variable alone. So the only way to get a power of 2 out of one variable is if you square the variable. X by x is x squared. X, let me write it down now. Right? If you have a bivariate quadratic, you can get a power of 2 by multiplying the x and the y. You ain't seeing a 2 there, but the power 2 is there implicitly because of the 1 here and the 1 here. If it is one variable alone, the only way you can get a power of 2 is x by x, which is x squared. Or if the variable happens to be y, y by y, which will be y squared. Alright? So we're going into a little extra detail at the beginning here because I want people to be absolutely clear. When they hear the word quadratic, when they see quadratic written in an exam, what it is we're talking about. And I want people also, when they see it, you must be able to look at it and say, hey, that is a quadratic. And that recognition would then set in motion a chain of events depending on whatever they ask you to do with the quadratic. Whether they wanted to factorize the quadratic expression, whether they wanted to solve a quadratic equation, whether they wanted to complete the square, whether they wanted to use the quadratic formula, whether they wanted to sketch the quadratic, whether they wanted to find the roots of the quadratic equation, right? Etc., etc., etc. There's a whole lot of things, as you would realize by now, that can be done with quadratics. This is just one thing that we're dealing with here now, which is the factorization. All right, so the next thing about recognizing a quadratic is recognizing the values of the coefficients in the quadratic. So the first thing we need to do is to understand what exactly a coefficient is and where are the coefficients in this particular general quadratic. We deal with the general quadratic first and then we'll deal with some of the examples that we have here on the board. So let me just pull some Google here and define the word coefficient, right? I know what it is and people who do any maths will know what it is, but it is always nice to have your definition. All right, so what is a coefficient? Let me see. A coefficient, coefficient, come fast. Coefficients, coefficient, C-O-E-F-F. Right, the meaning of coefficient, according to Google, in mathematics, a coefficient is a numerical or constant quantity placed before and multiplying the variable in an algebraic expression. Let me read that again. All right. A coefficient is a numerical or constant quantity placed before and multiplying, very important, the variable in an algebraic expression. All right. We already discussed that in this general quadratic, the variable is x. Right. So you have x squared and then you have x here. Right. Those are the two versions of x that appear in this general quadratic. In front of the x squared we have a. That a is the coefficient of x squared. In front of the x we have b. That b is the coefficient of x. C across here is not a coefficient. C is just c. This c is a constant. Alright? Now the coefficient is not a, sorry, let me be careful. The coefficient is not a variable. So even though you see a here and you see x squared, and you know that x squared is a variable, don't make the mistake of thinking that because a is a letter, a is also a variable. No. A is a constant that could take any value. So in this expression here, 2k squared plus 3k minus 45. Let me just change the color of the ink. Sometimes the green don't show up too brightly. Right? You have 2k squared plus 3k minus 45. In this expression, your a is equal to 2, your b is equal to 3, and your c is equal to minus 45. So let me give you a little more vocabulary here now. Right? So pay close attention. What we have here is what we refer to as a quadratic in K. In other words, K is the variable. This here is the general quadratic in X. Right? You have a quadratic in X. Here, you have the quadratic in K. What the in X and the in K means is that the X is the variable in this case here, and in this case here in blue, the K is the variable. Alright, let me just make the colors a little more consistent so we could avoid the confusion. So this here is a quadratic in K, and this here in red is a quadratic in X. Right? And of course you can have a quadratic in any variable. So over here you have a quadratic in W, over here you have a quadratic in Y, over here you have a quadratic in P. So even though we use ax squared plus bx plus c as the general form of the quadratic, understand that the variable could be represented by any letter, and it doesn't even have to be an English letter. So for example, you could have a quadratic in, let me say, alpha, right? You could have alpha squared minus 3 alpha plus 32. That's a quadratic too, right? So it could be anything. It could be anything, right? Nice. So you have your a, which is the coefficient of x squared, which is also referred to as the leading coefficient. And there are other applications of quadratic where the value of the leading coefficient or the sign of the leading coefficient is a big deal. So there are certain situations where if your a is negative, something will happen. If your a is positive, something else will happen. That's the leading coefficient, right? Your a is the leading coefficient, and then you have b. So you have two coefficients, and then you have the constant c. Now, as you can see, between these four expressions that we have here, again, let me just change the color. 11w squared minus 44. 11w squared. Want to see how dynamic these sections are? 9y squared minus 65y. Organic is the word. 9y squared minus 65y. And down here we have minus 12p squared minus 13p plus 6. Okay? Minus 12p squared minus 13p plus 6. Alright. So you have a quadratic in K, you have a quadratic in W, you have a quadratic in Y, and you have a quadratic in P. Now we look at these four examples and you realize that you have two that appears exactly like the general one we have in red here. Right? That would be this one here and this one here. Right? So in this one here, we could clearly see that A is equal to 2, that B is equal to 3, and that C is equal to minus 45. In this quadratic here, we could clearly see that A is equal to minus 12, that B is equal to minus 13, and that C is equal to 6. We could see that. These two, however, it's looking a little different. And why is that the case? That is the case because your B or your C could be 0. Or both of them could be 0. So for example, if I put x squared as a quadratic, right? Your A is equal to 1, your B is equal to 0, and your C is equal to 0. Right? If I put 7c squared. That's a quadratic too. A quadratic in C. Once you see the square, you know it's a quadratic. So in other words, this must be present. So in other words, your A must be present for it to be a quadratic. A, of course, being the coefficient of x squared. So it must have an x squared, or a y squared, or a p squared, or a k squared, or a w squared, or a y squared, or a c squared, or alpha squared, as we discussed earlier on, for the expression to be considered a quadratic. Alright? And once you have this squared, there will be a coefficient. Even if the coefficient is 1, by implication, implicit, you wouldn't always see the 1 written explicitly, but it is there. So if you see x squared hanging by itself, you know that a is equal to 1. Even if b and c are equal to 0, as we have here. 7c squared, b is equal to 0, your c is equal to 0. Don't mind we use c as the quadratic, right? But you understand the point I'm trying to make. Over here, we could clearly see that a is equal to 11, your b is equal to 0 because we don't have anything in w. We don't have nothing in w. We have 11w squared, so we know a is 11. We don't have anything multiplied by w. And then we have the constant c, which is equal to minus 44. 9y squared minus 65y. We could see clearly that a is equal to 9, right? Your b is equal to minus 65. Minus 65, of course, being the coefficient of y. And of course, your c will be equal to 0 because you don't have a constant. So you have two coefficients and one constant. Your constant could be equal to 0, as you see. Your b could also be equal to 0, as you have here. In this example, your b was equal to 0. In this example, your c was equal to 0. The one entity that cannot take a 0 value in a quadratic is e. Because if the a disappears, what you will in fact have is bx plus c, which is a different type of expression. That is a linear expression now, where the highest power is equal to 1. And of course, if the expression is linear, which means the highest power is 1, you could only have one variable in a linear expression. Alright? So if you have a quadratic expression, and for some reason the value a is equal to 0, then that is not a quadratic expression. That's a linear expression. Or it could be a constant. Because if a is equal to 0, this is a linear. If your c is equal to 0, that's a linear. If you have bx plus c, right? And then your b is equal to 0, then bx will disappear, leaving you with c alone, in which case c will be a constant standing by itself. Alright? So a lot of talk at the beginning just to discuss what a quadratic expression is, just to discuss what it looks like, just to discuss the recognition of a quadratic expression. And now we're in a position where we can actually start the factorization, because we're going to use all of these concepts in the factorization itself. So one thing I want to say before we start the factorization is that your tables, your multiplication tables, very, 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 very important. As you would have guessed by now if you were doing the factorization prior to this, the ability to recognize factors, common factors, that stems straight from your multiplication and your division tables. That is something, if you're weak in that area, then you have to give it some practice. You have to give it some thought, you have to give it some effort. Right? If you decide to be persistent at this level, notwithstanding previous weakness in your tables, you will very well find that the tables itself will improve, because you will be forced to get into numbers. This multiplied by this is that. This divided by this is that. You have to do that. And by sheer repetition, if you do enough, you will find yourself starting to improve. Which takes me back to the values that I try to pass on to my students and to anybody that I have the opportunity to discuss maths with all the time. Maths fundamentally is not about natural talent. Yes, everybody will not be Einstein, right? Or Isaac Newton, or whoever else, right? Gauss. We have a whole series of great mathematicians in the history of the world, right? But everybody could get to a decent level, right, with sufficient work. So in other words, two people with different levels of natural ability will put in the same amount of work and they'll get different results, and that is fine. The important thing is that whatever your natural ability is, that you max that out, and that you tell yourself, all right, let me see if I could push a little beyond the max now, right? That is the idea. If your max is 65 and you get 70, well, then your achievement is just as great as the person whose max is 90 and get 95, right? If your max is 80 and you get 90, then the person whose max is 100 and get the same 90, you can't put them in the same boat, so to speak, right? The point I'm making is that whatever your natural ability is, you have to max that. And you know the irony about it? The irony about it is that a lot of people don't even know how much natural ability they have, right? As somebody teaching over the years, I just digress now a little bit here. Somebody teaching over the years, I have had the experience more than once of coming across people with some scary levels of natural ability. And I say scary in a good way. Scary, frightening. When you see the kind of things that they do, and they don't even know what they just do. And I, as a mathematics person, tell them, well, wow, you're real good, you have real talent, you could do this thing. I'm trying to encourage them, and they don't even have a frame of reference to understand what I'm telling them. And they just amble along, lazy peasy, and they get that 3, they get that 2, whatever, and they just breeze in. Right? A big part of what I do here is I try to encourage people to maximize their talents, whatever your talent is. Right? Not to invoke any kind of religious imagery, but in the Bible there's a parable of the talents. Right? One person got 1 talent, one person got 5 talents, and the other person got 10 talents. And I am sure that there are similar stories and lessons in other religious constructs. So don't try to accuse me of dabbling in one thing alone. That's my frame of reference. Your frame of reference might be different, but I am sure the essential lesson is there. Wherever it is, find it. And even if you're not a religious person, a concept is a concept. Max out your talent, max out your ability. We call it maximizing your potential. However you want to describe it. The idea is to max it out. Right? Your level might be different than our next man's level. In some cases, you might have more than our next man in terms of natural ability. In other cases, the next man might have more than you. Don't worry about the next man. Max out yours. Right? And Once you do that, you have no problem. You can be satisfied and you can make whatever contribution you have to make to whatever space that you occupy. Right, so a little philosophy in the thing. So we're going now. So we're talking about the quadratic. All right? So we have different levels of quadratic expression. And in the course of this part of the discussion, I will go through some examples. I will explain the procedure. I will illustrate it. So I want you to pay very careful attention. What I would suggest that you do at this point is to get yourself a pen and a paper, notebook, file page, whatever, and follow what I say, follow what I do on the board by hand and not just by ear and by sight. So in other words, when I write, and there'll be a lot of writing coming up, you write too, right? That's a whole different world in terms of your muscle memory, in terms of your neural cortex, right? Making that connection between what you see, what you hear, and what you write. You bring your whole body into the process. Big, 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 big part of it, right? So I want to encourage you all strongly to write. So take some time and get your pen and paper. In the meantime, I will clean the board. And let me get this show on the road. Okay, so we're ready to start the factorization now. The method we're going to use is a method that is, I've seen it described as the product sum method. I've seen it described as the AC method. And I've also seen it described as the bomb method. Now we could figure out why they refer to it as the product sum method and why they refer to it as the AC method. And you will see that as we go through the examples in a little bit. I'm not too sure why people would call it the bomb method. There must be a reason, but I will find it out at some point. Right? So let us start with my favorite quadratic. Well, one of them. X squared plus 3x plus 2. I like to start with this quadratic whenever teaching, right? So I'll do the same thing here. The first thing you need to do when you're factorizing a quadratic expression is to write out the values of the coefficients and the constants. So in this case, your A is equal to 1, your B is equal to 3, and your C is equal to 2. Right? Your next step is to multiply A by C. So hence why they call it the AC method. You multiply A by C. So A by C, AC is equal to 1 multiplied by 2, which is equal to 2. The next step now is, having obtained the product AC, you're now going to look for two factors of this product that are also addends of the coefficient B. It sounds confusing. Let me illustrate using general terms and then we'll go specific. So basically what we're looking for is two factors, which means that F1 multiplied by F2, factor 1 multiplied by factor 2, must be equal to AC. Right? Must be equal to AC. And those two factors must add together, hence the term addends. Those two factors are addends of the coefficient B. Right? So factor 1 by factor 2 will be equal to 2. Factor 1 plus factor 2 will be equal to 3 in this particular instance. And we will go through the same process with all the other questions as we go along. Alright? Nice. So, continuing along now, let me just get rid of this because we need the space. Right? We have the small board. So, you want to find two factors of 2. And as you will see shortly, we'll get bigger numbers, which means more factors. Right? So, we don't want to guess what these factors are, which is what a lot of people do. And so far in my own readings on the topic, I haven't really seen people put together a system, a foolproof system by which somebody could find the factors. So I'm going to introduce one here now in this video. A foolproof system that you could use if you have any doubt about the factors, and you will find that as you use it more and more often, you will get to the point eventually where you could figure it out mentally in your head. Right? But of course, my advice would be, if you're not there yet where you could figure it out mentally, you could adopt this particular system that I'm going to introduce now, by which you could find the factors. And I will illustrate it for the small products, like how we have 2 here, and then you'll see bigger products later on. So 2, you start with 1. You always start with 1. 2 is equal to 1 by 2. But 2 is not only equal to 1 by 2. 2 is also equal to minus 1 multiplied by minus 2. So that's another concept we introduced in here now. That is a concept that I refer to as the mirror. So after having found the 2 factors, positive factors, which if AC is positive, then yeah, you'll have a pair of positive factors. No problem. We could pick that up fast. You have to remember also that if a product is positive, you could get a positive product by multiplying 2 negative numbers, right? A minus by a minus is a plus, as we like to say. All right? So since 2 is a prime number, the only 2 pairs of factors that we'll be dealing with is this pair and this pair. So which one of these pairs are such that the factors are add-ends of the coefficient b? In other words, factor 1 plus factor 2 is equal to b. In this case, b is equal to 3. Factor 1 here is 1, factor 2 here is 2. 1 plus 2 is 3. So there we have it here. So this is the pair of factors that we're going to use to continue with the working that we're going to do now. Alright? This pair here. So what's the next step? The next step would be to write the original expression, but instead of writing b, you write b as the sum factor 1 plus factor 2. So what you're going to have here would be what you're going to have here would be x squared plus 2x plus x plus 2, or you're going to have x squared plus x plus 2x plus 2. Why do I say that? I say that because you could write 3 either as 1 plus 2, or you could write it as 2 plus 1. Right? So 3x is 2x plus x. You write over this 3x as 2x plus x. That's the same 1 and 2 you got from the factors of AC. Or you can write it as x plus 2x. 1x plus 2x is still 3x. Right? Once you get to this point now, the next step is to factorize by groups. So we're just going too fast because we already discussed that in our previous video. So the next line here will be x into x plus 2 plus 1 into x plus 2. You take out 1 as a common factor here, because whatever is inside this bracket must be the same in this bracket. Right? You take out the common factor x plus 2. X plus 2 is a common factor into x plus 1. We discussed that in the factorization by groups. Or, on this side, you could have x into x plus 1 plus 2 into x plus 1. In this case, the x plus 1 is the common factor, leaving with the x plus 2 on the inside. Alright? So I just want to speak very briefly on something here. Right? Over here versus over here, the particular mathematical property that we employed there is the property of commutative. The commutative property. Commutativity. Well, the commutative law, where an operation is commutative if the order in which you perform the operation on the operands, the thing that they're operating on, doesn't make a difference to the result. So we know, for example, that 2 plus 3 is equal to 5. We also know that 3 plus 2 is equal to the same 5. We know that 2 multiplied by 3 is 6. We also know that 3 multiplied by 2 is the same 6. So in other words, multiplication at this level is commutative, and so is addition. Right? You can't say that it is always commutative because there are other types of operations where it may not be so. But for what we do in here, and in general use for most people, the operation of addition is commutative. 2x plus x is the same thing as x plus 2x. And the addition of multiplication is commutative. X plus 2 multiplied by x plus 1 is the same thing as x plus 1 multiplied by x plus 2. That means, therefore, that when you're factorizing a quadratic, after you get the factors of AC, it matters not in the slightest whether you put 2x plus x or x plus 2x. It matters 0. And I'm making this point because I get that question all the time. And that is a very common question that I would have gotten over the years teaching this topic. You spend some time and you illustrate it using 2x plus x. And then somebody with a lot of concern in their voice would pipe up and say, sir, so if I put x plus 2x and I get x plus 1 multiplied by x plus 2 instead of x plus 2 multiplied by x plus 1, is it correct? I have to tell them, yes, it is correct. Right? These are some of the little things that sometimes people are not too sure about. And something as simple as that could breed uncertainty. Not uncertainty, uncertainty. Could breed uncertainty in a student. And once they get that uncertainty now, you could get a spiral effect. And before you know it, your confidence is gone. And you tell yourself, I can't do quadratic factorization, when he was going on the right track, just 1 or 2 little things that needed to be cleared up here. That's why we clean up all that now. Alright, so that is it for this one. So let me switch the game now and introduce another quadratic. Right? You have, right? Doing them in groups where the quadratics resemble each other. The only difference is that the quadratic will increase in complexity as we go along, just to illustrate that whether it is a straightforward one or whether it is a little more complex, the procedure is the same. Alright? So 2x squared plus 11x plus 12. Right? So if we have, come board, China man. Right? Our next quadratic. In this particular series we're doing here now. 2x squared plus 11x plus 12. Right? So you see that a little more complicated now because the a is equal to 2. Just now the a was equal to 1. Right? A lot of folks will factorize very well when a is equal to 1. But the minute a is equal to something else other than 1, we have a problem. Well, let me go through it. So again, you write out the values. A is equal to 2, B is equal to 11, and C is equal to 12. Again, your first step is AC, right? Again, your product. So that's why they call it product now. You have AC is equal to 2 by 12, which is equal to 24. Now we're looking into factors of 27 whose sum will be 11. You want 2 factors that are add-ins of 11. Add-in. A, D, D, E, and D. The add-in is simply the numbers that you add to get a particular sum. Right? Nice. So, as we did just now, we start at 1. So 24 is equal to 1 by 24. It is also equal to minus 1 by minus 24. We're making sure to add the mirrors. Right? 1 and 24 clearly wouldn't add anyhow to give us 11. So let me try 2. 2 by 12 is 24. Minus 2 by minus 12 is also 24. No way you could combine 2 and 12 to get 11. So let me try 3. Okay, 3 could go into 24, right? 3 by 8 is 24. Minus 3 multiplied by minus 8 is also 24. And boom, suddenly we have something here that we could work with. So the factors that we're looking at would be 8 and 3. So those are your factors whose sum is 11. 8 and 3 is 11. So in other words, 8 and 3 are the add-ends of 11 in this particular case, right? And just one quick note, in this particular setup, there will be one and only one pair of factors that will satisfy the particular condition of also being add-ends of the coefficient b. Only one. Even if we have to go through a whole list of possible options, as you can see here, we went through some more options than we did in the last time, in the last question. And in the next question, we'll go through even more options. Sometimes you might have to take a little while to get the pair of factors. But as you get better at the topic, you will find that you could get to the pair of factors without having to go through every single possible pair. But we're doing this for the sake of instruction, right? For the folks who might be having a little problems with it. So your next step, as we discussed a little while ago, so you see the product sum, right? This is your product, 8 plus 3 equal 11. That is your sum. Hence, why we refer to it as the product sum method in some quarters. In other quarters, we refer to it as the AC method. As you can see here, A by C is your first step, right? We still have to figure out why they call the bomb method in other places, right? Right, so your next step would be to write over the original expression, as we did just now. And we're saying now that you have 2x squared plus 11x plus 12, sorry, not 11x, my mistake. 2x plus 3x plus 8x plus 12. I can write it over like that. I can write it like that, right? Or I could write it as 2x squared plus 8x plus 3x plus 12. My personal preference would be, having gotten it, well, it wouldn't really matter, right? But based on the system we're operating from here, where you write 1 by something, 2 by something, 3 by something, you start with the smaller number first. So we got 3 by 8, so I would put 3x plus 8x. But again, other people might put 8x plus 3x, and that's fine. So you factorize by groups. Again, we're just going through quickly, right? X into 2x plus 3 plus 4 into 2x plus 3. And then you have 2x plus 3 as the common factor into x plus 4. On this side, this version, you have 2x squared plus 8x here, so you factorize by groups again. You have 2x into x plus 4 plus 3 into x plus 4. So you have x plus 4 as the common factor into 2x plus 3. And that's it, you know. That is it. Plain and simple. Right? As you see, both versions are equally correct. Of course, in an exam, you choose one version and you run with it. Alright, so we're going again. Next one. Again, follow. Try and write while you're doing it, because I'm doing a lot of examples here. So if you take your time and go through this video with me, it'll make a big difference when you finish. So the next one, 15x squared. 15x squared plus 16x plus 4. So you see what happening here. So as we did in the last two examples, you write out your values. Your A is equal to 15, your B is equal to 16, and your C is equal to 4. So your AC is equal to 15 multiplied by 4, which is equal to 60. Much bigger number now with a whole lot more possible pairs of factors. So guessing the factor here might be a little more tricky. Not guessing, sorry. Getting to the factor mentally would be a whole lot more tricky than in the first case where AC was equal to 2. Right? So there we go. 60 is equal to 1 by 60, but it is also equal to minus 1 by minus 60. We're sure that can work. So we try 2. 60 is equal to 2 by 30. You see we have the order anything, or minus 2 by minus 30. 2 ain't working either. There's no way you could combine 2 or 30. 2 and 30, even on the mirror side, to get 16. Right? So we try 3. 60 is equal to 3 by 20, or minus 3 by minus 20. That ain't working either. So we try 4. 60 is equal to 4 by 15, or minus 4 by minus 15. How about 5? 5 by 12, or minus 5 by minus 12. That ain't working either. But then we could try 6 by 10, or minus 6 by minus 10. How about that? Boom! We have something here. 6 by 10 is 60. That's multiplication. 6 and 10 are factors of 60. And 6 plus 10 is equal to 16. So 6 and 10 are add-ends of 16. So this is the pair of factors that we're going to use in the next step. So we're rubbing off here now. And the next step would be, right? The next step would be to say, writing over this thing. 15x squared plus 6x plus 10x plus 4. Alright? We factorize, so you get what? 3x into 5x plus 2 plus 2 into 5x plus 2. Of course, you take your 5x plus 2 on the outside as a common factor into 3x plus 2. If you had chosen to write it instead of 6x plus 10x, if you had chosen to write 10x plus 6x, it would then be 15x squared plus 10x plus 6x plus 4. In which case the factorization will give you 5x into 3x plus 2 plus 2 into 3x plus 2. And that now will give you 3x plus 2 into 5x plus 2. And as we discussed earlier on, same difference on both sides, end of discussion, where that particular question is concerned. So we would have done 3 examples where your B was positive and your C was also positive. Folks could run through that no problem, because everything is straightforward when it's always positive signs. Right? We're going to introduce the negative sign now. And as you know, once the negative sign steps in the dance, once the negative sign enters the picture, things get a little more complicated. Right? But as always, you take your time and you get what you have to get. Right. So we're going again. So we're starting over with a new permutation now. Right? Remember in the previous videos we had different permutations of the same type of question. Same thing happening here, as you would notice with the quadratic factorization. This time we're dealing with a quadratic where your B is negative and your C is also negative. So the first one in that group would be x squared minus x minus 2. See? Thing looking different now, but the procedure is the same. You just have to be careful with your minus signs. Your A is equal to 1, your B is equal to minus 1, and your C is equal to minus 2. Alright? So here AC is equal to 1 multiplied by minus 2. Note how we write the thing there now, which is equal to minus 2. Aha! Different kettle of fish now. Because in the first set of questions, we had AC is equal to 2, which meant that the pairs of factors would have been all positive, 1 by 2, or all negative, minus 1 by minus 2. This time your product AC is negative, which means, therefore, that if you're multiplying two numbers to get this negative number, minus 2, then one of the numbers must be negative. So, if we take the approach of starting with 1 again, it means that minus 2 is 1 by minus 2. It could also be minus 1 multiplied by plus 2. And because 2 is a prime, that's all the factors we have to consider in this case. So which one of these two pairs would give us numbers that are add-ends of minus 1? The answer would be 1 and minus 2. 1 minus 2 is minus 1. So again, with the minus signs, you have to be so careful, right? And as we go deeper into the examples, you will see the difference between one pair of factors and another pair of factors, right? So stay tuned. So in this case, we're going to continue by saying, we're writing over the original expression now, x squared plus x, careful now, minus 2x minus 2. You factorize by groups, x into x plus 1 minus 2 into x plus 1. And then you factorize the x plus 1 into x minus 2. Again, the alternative form is to write it over differently and say x squared minus 2x plus x minus 2, right? If we had done that, we would have ended up with x into x minus 2 plus 1 into x minus 2. You take the x minus 2 out as a common factor into x plus 1. And as we discussed already, the version on the left side here is the same as the version on the right side here by virtue of the commutative property. Right? Nice. Next one. We're going again. So this one now, 2x squared minus 5x minus 12. Well, let's see how nice it is. It's nice. Right? Oh, dry now, man. Dry now, man. All right, let me rub off just at the board. 2x squared minus 5x minus 12. Another one of my favorite quadratics. I have a few that I like to use, you know, when I'm talking about quadratics in front of a class. Alright? So 2x squared minus 5x minus 12. Beautiful. Alright. So your a is equal to 2. Your b is equal to minus 5. Don't skip this step, eh? And your c is equal to minus 12. No problem. So your next step is to multiply a by c. So ac is equal to 2 by minus 12, which is equal to minus 24. So again, just as we had in the last one, negative ac means that when you're multiplying the two factors, one of those factors will always be negative. Right? So you start with the 1. 1 by minus 24. Or you switch the signs to give it the mirror here. Minus 1 multiplied by plus 24. That ain't working. We try 2. 2 by minus 12 or minus 2 by plus 12. That ain't working either. We try 3 by minus 8 or minus 3 by plus 8. Yeah, we look like we have something here. 3 by minus 8 plus minus 3 by plus 8. Right. So we have here 3 and minus 8, which are two factors of minus 24, which are also add-ends of minus 5, because 3 plus minus 8 is minus 5. So let me just make one thing clear here. Right? Even though we refer to them as add-ends, you see in 3 and minus 8 here, this 3 minus 8 is actually 3 plus minus 8, which will give you 3 minus 8, which will give you a minus 5. Right? Or you could say alternatively minus 8 plus 3, which will give you a minus 5. So in addition to your multiplication tables, your ability to multiply and to divide and to know what is what where the multiplication and the division are concerned, your ability to work with negative signs is also a big part of the quadratic factorization. But as is the case with the multiplication and division tables, even if you're not so strong with the negative numbers, if you decide to persist at this level and do enough questions, you will find that even in there, while you're working on the quadratics, your plus and a negative, that will also improve as well. So again, just to underscore the value of simple, good old-fashioned persistence. Very important. All right? Nice. So we're writing over. We continue. So we're saying now that this is equal to, writing it over, 2x squared minus 5x. No, not minus 5x. This will be minus 3x plus x minus 12. You factorize, you get x into 2x minus 3 plus 4 into 2x minus 3. Alright? And then you have 2x minus 3 into x plus 4. Of course, if you had written it as 2x squared, sorry, this is plus 3 minus 8x. My mistake, boy. Ja, you see how careful you have to be when you're doing this thing? So this is 2x plus 3 minus 4. Aha! Into 2x plus 3. So let me make a little statement here now. Right? When you're factorizing by groups in the course of doing a quadratic, sometimes this minus sign here will cause problems and people not sure. So let me give you a little hint. Let me give you a little trick. Because the overwhelming majority of questions at this level will involve positive values of a, you wouldn't get minus 2x squared plus 5x plus 12. You'll get at a harder level, maybe in section B in CSEC maths or maybe in add maths or whatever it is. But for general maths, where we're building the foundation here, you usually work with positive a's, which means 99 times out of 100 that when you write it out as a quadrinomial, 4 terms, you will be starting with a positive value here, which means that the factorization will be a lot more straightforward. You could pull out a factor braps. Make sure you do this correctly. Once you do this correctly, you'll know that in the course of finishing the factorization, that whatever you have inside the bracket here must be the same as what you have in this bracket here. And you could start with that. So you could just put it here, braps. So in other words, you're doing it and you ain't too sure what to do. So you say, well, all right. We rub off just to make the point. You say, well, all right, x into 2x minus 3, no problem. We're good with that. You ain't really so sure what to do here because you have 2 negative signs. So you see negative signs now. Pressure, right? So here what you do. You put the bracket, just as we would have done in the very first 2 videos. Univariate binomial and the bivariate binomial. Same techniques come into bear again here. You put the same 2x plus 3 here inside the bracket. So now you had to multiply something by 2x plus 3 to get back minus 8x minus 12. So now that you know that it's 2x plus 3 inside here, you could fiddle around and see what you're taking on the outside here. Right? You ain't so sure what this is yet in terms of the sign. But you know this is 2x plus 3. So the only thing that can multiply by 2x to give you a minus 8x is minus 4. And then you double check now Minus 4 by 2x is minus 8x. Minus 4 by plus 3 is minus 12. And once you're sure about that, you take out the 2x plus 3 as a common factor into x minus 4. Problem done. Alright? So that's a little trick there that you can employ as you go along. Over here now, if we had done it as 2x squared minus 8x plus 3x minus 12, you would now have 2x into x minus 4 plus 3 into x minus 4. You take your x minus 4 as a common factor into 2x plus 3. Right? End of discussion. Same story here, same story over there. Moving right along. Next one. So you see, once you start to get a hang of it, you find that you will go through these things a lot faster. And that is what I want for you. But it might mean going slow first. Right? If you have to go slow first, take your time. The speed will come. Alright? So the next one is 15x squared minus 4x minus 4. 15x squared. Don't mind my hand looking a little dirty there. Nice hard work, right? 15x minus 4x minus 4. So again, you write out the values. A is equal to 15, B is equal to minus 4, and C is equal to minus 4 as well. Alright, no problem. So your AC is equal to 15 multiplied by minus 4. Note the difference between how we write the positive 15 by minus 4. Sorry, the positive 15 by 4 versus 15 minus 4. Now we could also write 15 by 4 here, like that, in the case where A and C are both positive. Right? Anyhow you do it, just take your time and do it properly. Right? So 15 by minus 4 is minus 60. Aha! Same story here. Bigger number, more pairs, negative product, which is to say then that if we're dealing with two numbers multiplying to get minus 60, then one of those numbers must be negative every time. So we start with 1 as always. Minus 60 is 1 by minus 60 or minus 1 by plus 60. It is 2 by minus 30 or minus 2 by plus 30. It is 3 by minus 20. It is also minus 3 by plus 20. That time working. 4, we can run through that a little faster now because we have these numbers and we know that none of these numbers here will add to give you minus 4. So 4 by minus 15 or minus 4 by plus 15. We try 5. 5 by minus 12 or minus 5 by plus 12. Or we could say 6 by minus 10. Aha, something happening there. But just for the sake of completeness, I will include the mirror here. Minus 6 by plus 10. So you see with the mirror, we switch the signs. So we had 2 plus 2 by minus 30 here. And then with the mirror, we switch to minus 2 by plus 30. Right? You must consider your mirror because sometimes the factor will be in this column on the mirror side as opposed to this column on the initial side. Yeah? So 6 by minus 10 is minus 60. 6 plus minus 10 or minus 10 plus 6 is minus 4. Alright, so we're going again. Rubbing off now because we're on the small board. So we had to rub off to make space. Well, let's see. So 6 and minus 10, this will be what? 15x squared minus 6x plus 10x minus 4. You factorize. That will be 3x into 5x minus 2 plus 2 into 5x minus 2. So that will be 5x minus 2 as a common factor into 3x plus 2. Or you could have written it as 15x squared plus 10x. Some people prefer to write a bigger number in front. Right? No problem. So you factorize. You get 5x into 3x plus 2. And again, you ain't sure about this with the minus sign. So you say, alright, here what? You know we're going with 3x plus 2 on the inside here, because we already have 3x plus 2 here. So what we multiply by 3x plus 2 to get minus 6 minus 4, that will clearly be minus 2. So it will be 3x plus 2 outside as a common factor into 5x minus 2. End of conversation. Alright, so we finished 2 sets of expressions so far. 2 particular combos. One is plus plus for B and C. The other one is minus minus for B and C. So the next 2 we're going to be dealing with will be plus minus B and C, and then minus plus B and C. So that way we cover all the possible ways in which the quadratic could appear. Given that A is positive, we're restricting ourselves to positive values of A only in this video. I will do a separate video where we're going to consider values where A is negative. We will treat that as a separate thing. And again, you will find even there that once you go along and you take your time with the maths and you adhere to the procedure, you will get it out, right? But we can't squeeze everything into one place. So, our next video for that. All right, so next one. Let me clear the board. I hope all right in now. All right? I hope all right in. So we're going again. X squared plus x minus 2. Again, so we're starting off with a simple one. X squared plus x minus 2. So your A is equal to 1, your B is equal to 1, your C is equal to minus 2. Alright? So your AC is equal to 1 by minus 2, which is equal to minus 2. And again, minus 2, we starting with 1. 1 by minus 2 or minus 1 by plus 2, right? So as we get into more and more questions, you find there's less need for talking, less need for explanation. We could just get straight into the action. And that is what happens when you practice. The first few will be slow and tentative and you're sure you'll make some mistakes, you bounce head a little bit, and then boom! By the time you do a few, and then you do a few more, and then you do a few more, you start to realize the rhythm coming. And then that rhythm will translate into speed. Speed of thought, speed of execution. And not just speed, but accuracy. Because you would have taken your time to go through the process in the slow phase to make sure that you were doing the thing correctly. That is what we're looking for. Right? So, what pair of factors here will give us plus 1 when we add them together, right? Your B is equal to 1. You want 2 pairs of factors, well, 1 pair of factors, both of which are add ends of plus 1. So, you can clearly see that minus 1 plus 2 will give you plus 1. So, we proceed. So, you write it over as x squared minus x plus 2x minus 2. You factorize x into x minus 1 plus 2 into x minus 1. X minus 1 will come out as a common factor into x plus 2. Or alternatively, if you had written instead x squared plus 2x minus x minus 2, you factorize x into x plus 2 minus 1. And I'm going through it a little fast now. Minus 1 into x plus 2. Again, of course, some folks will have this down. No problem. They could factorize, taking the negative number out. Other folks who are not quite there yet will need to do as we just discussed and put the bracket down first and say, well, alright, x plus 2, we have x plus 2 in here. What multiplied by x plus 2 will give us minus x minus 2. You must consider the minus in front of this x here, right? And the answer is clearly minus 1. So then you take x plus 2 outside as a common factor into x minus 1. Alright? Nice. So we're moving along. Speed, man, speed. Alright? We're going again. Yeah, we getting through this thing, man. Well, let's say it. The nice thing about the video is that you have the option to pause and stop and rewind. Use the rewind button, eh? Yeah, right? So 2x squared plus 5x minus 12. 2x squared plus 5x minus 12. Your a is equal to 2. Your b is equal to plus 5. And your c is equal to minus 12. Alright, no problem. So your AC is equal to 2 by minus 12, which is equal to minus 24. And we're going again. Right? Of course, by now you will start to see the patterns because you realize the similar numbers we use, and the only thing that changes really are the signs. But for the sake of instruction, I am still going to go through everything as if it were a new problem, a fresh problem, something that we've seen for the first time, not having seen anything that even resemble it before. Alright? So minus 24 is 1 by minus 24. Nope. Or minus 1 by plus 24. No, no. How about 2? 2 by minus 12 or minus 2 by plus 12. Now I'm working. Hey, we have to refill this boy. How about 3 by minus 8 or minus 3 by plus 8. Aha! We have something here. Right? We have plus 5, which is a b, and we have here two factors, minus 3 plus 8, which would give you plus 5 when you add them together. So in other words, minus 3 and 8 are add-ends of 5. So those are the pair of, that is the pair of factors that we're using, right? So we're going again. So this would be, next step now, you write this over as 2x squared minus 3x, right? Minus 3x plus 8x minus 12. You factorize by groups now, x into 2x minus 3 plus 4 into 2x minus 3. And then you have 2x minus 3 as a common factor inside, multiplied by x plus 4. Or, alternatively, if you had written instead 2x squared plus 8x minus 3x minus 12, you factorize by groups, you get 2x into x plus 4 minus 3 into x plus 4. And again, you can get that by straight factorization, or you put your brackets, you put the x plus 4 in the brackets, and you figure out what multiplied by x plus 4 will give you minus 3x minus 12. The answer is minus 3. These are the little things that you will figure out on your own by practice. Everybody will figure out their own system to do it. I will give you a general guideline here, but everybody will figure out their own unique pathway to get to the correct answer. And that is one of the beautiful aspects of mathematics. You have 12 people in a room, you give one question, and you could find among those 12 people 3 or 4 or 5 or 6 different ways to do the same question. Sometimes somebody will pipe up and show you something that you never thought of in all your years of doing maths. That is one of my most treasured experiences anytime I'm teaching maths. Anytime a student of mine, some of whom may not have even been born yet when I was in school, when I was their age, so to speak, doing the maths. Sometimes it would be an adult student, a private student, somebody who probably didn't pass maths once, they didn't pass it twice, they didn't pass it 3 times, but You give them the freedom to express themselves in class, and boom, they throw stuff at you like, woo, pressure boy. I didn't think about it like that. I always like to encourage people to express themselves, so that, just express yourself, just make sure that you follow the basic parameters so that you get the correct answer. Right? Nice. Let's fix this mic here. Right, so in this case, the answer would be, you take your x plus 4 out as a common factor into 2x minus 3. And we done talk about that already, so we don't have to discuss that again. Alright? So we move straight on to the next one now. So we're finishing now, and we're saying 15x squared plus 4x minus 4. Right, so the next one, again, similar numbers, right? I deliberately chose these numbers just to show you the variations in the thing. Right? 15x plus 4x minus 4. Let me just clean the whole board first. 15x. 15x squared plus 4x minus 4. No problem. So your A is equal to 15, your B is equal to 4, and your C is equal to minus 4. No problem. Right? So your AC is equal to 15 multiplied by minus 4, which is equal to minus 60. Right? No problem. So we're going again. Minus 60 is equal to 1 by minus 60, or minus 1 by plus 60. Nope. It is also equal to 2 by minus 30, or minus 2 by plus 30. No. 3 by 20, or minus 3 by plus 20. 4 by, it's supposed to be minus 20 here. Right. 4 by minus 15, or minus 4 by plus 15. 5 by minus 12, or minus 5 by plus 12. Nope. That is 6 by minus 10, or minus 6 by plus 10. Right? So in this example, just as was the case in the preceding example, you found that the pair of factors that we're looking for will actually to be found in the mirror column and not in the column of initial factors. Right? So in this case, again, we're looking at 15x squared minus 6x plus 10x as you write over here. Alright? So 15x squared minus 6x plus 10x minus 4. Whew. I had to go and refill this thing, boy. Pressure! Yeah. It's hard work writing these things, you know. Markers under pressure. Right? No problem. Your pen might be under pressure too. But that is how we just get the result that we're trying to get. Right? No problem. No problem at all. Alright. We take out the empty one here and replace it with the new one. So that way when you write on the board you can see everything. So we factorize it now. So this will be what? 3x into 5x minus 2 plus 2 into 5x minus 2. No problem. Right? You take out the 5x minus 2 as the common factor. 5x minus 2 into 3x plus 2. So far so good. So how about if we had written it the other way around and said 15x squared plus 10x minus 6x minus 4. We would have had, we factorize here now, 5x into 3x plus 2 plus 2. Sorry, minus 2. Again, you get this either by straight factorization for those of us who comfortably enough there. Minus 2 into 3x plus 2. Or we start by putting the 3x plus 2 in brackets because we already had 3x plus 2 here. And then you go looking for your common factor, which when you multiply by 3x plus 2 will give you a minus 6x minus 4. So then you take the 3x plus 2 out as the common factor here into 5x minus 2. End of discussion. And that's it, you know. So in this case we had positive b, negative c. So the last case we're going to do now is the case where you have negative b and positive c. Alright? So again, we start off with where your a is equal to 1. Right? And we say that if we had x squared minus 3x plus 2. That is probably my favorite quadratic, but the reason for that is another discussion. Positive roots and all of that. 1 and 2, blah, blah, blah. Right? Don't worry about that. So x squared minus 3x plus 2. Your a is equal to 1. Your b is equal to minus 3. And your c is equal to 2. So again, your ac is equal to 1 multiplied by 2. Positive a and positive c, 1 by 2 will give you plus 2. And you have 2 is equal to 1 by 2 or minus 1 multiplied by minus 2. Positive by positive, you mirror that, negative by negative. No problem, right? Both of these will give you a positive product. But your b is negative. So in this case, the two negative factors will be the ones that we're looking for, which will be the add ends of the coefficient b. So we write this out as x squared minus x minus 2x plus 2. So x into x minus 1 minus 2 into x minus 1. Again, excuse. You can get it straight by factorizing, or in the case where I wasn't sure, you start off by factorizing x squared minus x as the group with the positive coefficient of x squared. The first coefficient being positive. And then you come here in your brackets and you say, well, alright, x minus 1, right? What by x minus 1 will give you 2x plus 2? What by x will give you minus 2x? Chances are the answer is minus 2. Where's it? Minus 2 by x is minus 2x. Minus 2 by minus 1 is plus 2. So then it will just be x minus 1 as a common factor into x minus 2. And again, if we had done the opposite, we know, if we had said x squared minus 2x minus x plus 2, then you factorize by groups, you get x into x minus 2, right? Same story here. We have a negative sign here in front of the first term for the second group. So you ain't sure, you say, well, all right, we already have x minus 2 in here, so we come in here with the x minus 2. That is the only way we could proceed. And then you try to figure out what by x will give you minus x. Minus 1 by x will give you minus x. What by minus 2 will give you plus 2. Minus 1 by minus 2 will give you plus 2. Right? And then you take out the x minus 2 as the common factor into x minus 1. End of discussion as we discussed previously. Moving along. We're going again. Right? We're going again. So we're coming now and we're saying, let me see. Yeah, just checking something on the camera there. So we're coming and we're saying 2x squared minus 11x plus 12. Again, negative b, positive c. Alright? No problem. We proceed. So, your a is equal to 2. Your B is equal to minus 11 and your C is equal to plus 12. No problem. So your AC will be equal to 2 by minus 12, which will give you minus 24. And again, as we always do, we start with 1. Minus 24 is 1 by minus 24. Or, sorry, plus 24. See what's happening again, tired? So, management of your fatigue is another factor in your preparation, right? You don't want to be working when you're tired. Find you whatever time your tired time is and make sure that you're not doing work during that time. Get your rest. Do your work. And then, of course, in the course of preparing for your exam itself, try to get your rest, try to get your sleep. If you want to go without sleep as part of your preparation, try to do that as long before the exam as possible. And then you could relax a little bit coming down to the end, right? Maths is the kind of subject where if you push hard early, you get your foundation in, you could relax coming down to the end and put yourself in a settled frame of mind going into the exam. That's part of your exam strategy, that's part of your preparation strategy, that is part of your cycle of rest and recuperation, right? A little tip and we're going again. So 2 by plus 12, not minus 12. 2 by plus 12 is plus 24. It's 24. And again, your 24 is 1 by 24. Or we bring in the mirror now, minus 1 multiplied by minus 24. Your 24 is 2 by 12. Or minus 2 multiplied by minus 12. Your 24 is 3 by 8. Or minus 3 multiplied by minus 8. What we have there? We have something there. Minus 3 by minus 8, boom, is equal to plus 24. That's factors. Minus 3 plus minus 8, minus 3 minus 8 will give you minus 11. So minus 3 and minus 8 are the add ends of minus 11. So those are the two factors that we'll be using in the next step, where we're going to say 2x squared minus 3x minus 8x plus 12, and then we factorize x into 2x minus 3, right, minus 4 into 2x minus 3. Again, you could have started by putting on the brackets, putting inside the bracket the same 2x minus 3 that you would have had here in your first group, and then having put that down, you then double check to see what will multiply by 2x minus 3 to give you minus 8x plus 12. You start by considering the minus 8x in isolation. So you say, yeah, let's check in something on the screen there. So you say, well, all right, minus 8x divided by plus 2x will give you minus 4. Or you could say, what by minus 2x will give you minus 8x? Sorry, what by plus 2x? Be careful. What by plus 2x will give you minus 8x. Minus 4 by plus 2x will give you minus 8x. And you double check. Minus 4 by minus 3 will give you plus 12. Right? Make sure you have your correct factor out there. So then you factorize and you get 2x minus 3 as the common factor outside into x minus 4. Again, in alternative form, this could have been 2x squared minus 8x minus 3x plus 12. So you factorize, you get 2x into x minus 4. Right? Again, minus 3 into x minus 4. Or, you're sure about the x minus 4 because you have x minus 4 here already. You might need to show about the minus 3. Here is the part where you need to slow down and double check your plus and your minus signs, etc., etc. Make sure that you have the correct factor outside. And then you have now x minus 4 into, as x minus 4 is the common factor, into 2x minus 3. So this little part here with the negative sign could be one of the issues that people have with the factorization by quadratics. But as you would have seen in the video so far, I'll give you a little trick, so to speak, that you could employ when you're factorizing. Just make sure you factorize the first group properly. Once you do that, the contents of the second bracket will be identical, the same as the contents of the first bracket. You double check to find what your constant is on the outside, and you proceed. Right? Nice. So the last one now in this series. The last one in this particular permutation, right, would be let me see, 15x squared minus 16x plus 4. 15x squared minus 16x plus 4. Your a is equal to 15, your b is equal to minus 16, and your c is equal to plus 4. So your AC will be equal to 15 by 4, which will be equal to 60. And again, we looking for the factors of 60, but we're looking for the mirror as well. We must consider the mirror as we discussed earlier on, right? So 60 is 1 multiplied by 60, or minus 1 multiplied by minus 60. Nope. We try 2. 60 is equal to 2 by 30, or minus 2 by minus 30. No. 60 is equal to 3 by 20, or minus 3 by minus 20. I will try 4. 60 is equal to 4 by 15, or minus 4 by minus 15. 60 is equal to 5 by 12. 60 is also equal to minus 5 by minus 12. Or 60 is equal to 6 by 10. 60 is also equal to minus 6 by minus 10. So which one are we using? Well, as you could see, minus 6 by minus 10 is plus 60. Negative by negative is a positive. Minus 6 plus minus 10 is minus 16. So minus 6 and minus 10 are factors of 60. Minus 6 and minus 10 are add-ends of 16. Sorry, are add-ends of minus 16. So let me run that over again. Minus 6 and minus 10 are factors of 60, positive 60 plus 60. Minus 6 and minus 10 are add-ends of minus 16. Right? So that way we could write it over as 15x squared minus 6x minus 10x plus 4. So you get 3x into 5x minus 2 minus 2 into 5x minus 2. Yes, this part will cause a little trouble for those who are not fluently familiar. Hey, how that sound? Fluently familiar with the factorization by negative. Factorization where you have negative numbers as part of the mix. And we cover that in the first two videos too. So if you're here and you didn't check out the first two videos, check it out. Right? Again, you put the same 5x minus 2 in the brackets, you check, you factor bram minus 2. So you take the 5x minus 2 as the common factor on the outside, and on the inside you have 3x minus 2. Or alternatively, you have 15x squared minus 10x minus 6x plus 4. You factorize, you get 5x into, don't worry about that, 5x into 3x minus 2. Again, you have a 3x minus 2 here. You're looking for the factor out here. that will be minus 2. So minus 2 by 3x is minus 6x. Minus 2 by minus 2 will give you a plus 4. So you have your 3x minus 2 as a common factor and the 5x minus 2. Right? And that's the problem there, no? Problem done. Right? So you have 5x here into 3x minus 2 here. I just going it over because I know it kind of crouch up in the corner here. 5x into 3x minus 2 minus 2 into 3x minus 2 here. Hope you're paying attention. And then you have your 3x minus 2 as a common factor. 3x minus 2 into 5x minus 2. And as we discussed, two sides, same difference. All right. So that, ladies and gentlemen, is the end of this particular video on factorization. Right? So we have covered what may be the most tricky part of the factorization. There are many folks who could do the regular factorization, but as soon as they put a quadratic in front of them, they have problems. Right? As we saw in this discussion, there are a lot of tiny little elements that come together when you're factorizing a quadratic. You had to know your tables. You had to be good with your plus and your minus signs, addition and subtraction. You had to be able to factorize by groups. You have to be able to get the factors of a product, and you also have to consider the mirror, which is the other pair with the signs flipped. A lot of different things coming together, but I took my time and I went through 12 examples. Various permutations, varying levels of difficulty. I trust that you would go through the examples as well and do the hard work. Do as much work as you need. Work as many questions as you need to work. Right? As I mentioned before, it doesn't matter what your natural ability is. There will always be people who will catch things faster than other folks in any discipline. But in any discipline, the folks who are willing to work will always get that progress. And that is what we're here for. Alright? So, I trust that you would have gained something from this video. We have another video coming up in this series, which will be Factorization 5. That video will cover what I like to describe as the easiest factorization you will ever do in your life. That is factorization of the difference of two squares. So stay tuned. We have more things coming up.